Hi, Sam Schiffman here. Welcome to my low budget series, What's on My Mind. Today I'm going to talk a little bit about what are the characteristics or features of a platform that could make agentic systems successful. So in my last video, I talked a little bit about why I've become convinced that agentic is the future. And in that video, to summarize it up, I basically talked about how non-deterministic systems are going to be able to break that barrier of usability that we've hit in computers and allow them to actually do what we want them to do all along, which is figure out how to solve the problems for us. And so that's going to be great, but they're going to need some underlying technology, some underlying platform that's going to make them work. So we talked about an agent, right? Which has an LLM, it's its heart, right? It has a prompt that interacts with it, and it has some tools and external memory. Right. I'm not going to go back over that, but I think one of the things is that we're going to rarely see an LLM operating, an agent operating in a vacuum. We're actually what we're going to see is networks of these agents working together. So we'll have you'll have an agent here and an agent here and an agent here, and they'll be talking to each other, right? And maybe there's another agent over here that only he knows about, right? Why is this? Well, I think, specialization is always important. What we've learned is that the best way to solve problems is to decompose them and to have specialization of the particular pieces of the solution. So this agent over here may be very good at understanding, say inventory, right? Whereas this agent over here might be really smart at understanding users, right? And this one over here might know about payment, right? But if you try to teach just one of these agents about all of these things, if they try to make them a generalist, they're generally not they're not going to be as successful, right? Because there's a lot to know about inventory and how to do that, a lot to know about payment. Those two separate domains. So I think that we're going to see networks of agents as our solution. And we've dealt with networks of systems a lot in computers. Very, very common network might be, let's say, online shopping, right? So you have a user over here, and they interact with a shopping cart, but they've also got an inventory system, right? So they go and they search the inventory, which puts things in their shopping cart. Then they do an order, right? So then they do an order, which takes the items in the shopping cart, goes out to payment, right? Then after payment, what it's going to do is go to inventory and subtract from the inventory, and then it's going to go to shipping and say ship the items out. Right, pick them out of inventory, pick them out, and ship them out. This could get much more complicated. There's many different ways that you could lay this out, but let's say this is our example. Okay, so as we build this system, what we've discovered is that this system can have a lot of problems in it, particularly if it's what we call synchronous in nature. So when a user starts their process of shopping, we start a single session that we consider to be synchronous. So he makes the calls and he builds his shopping cart, and then he does his order, right? And processes his payment. This is all happening in one synchronous thing. So each of these calls depends on every other call completing. So he's got to have this call, this call complete to put the item in his cart. He's got to have this call complete on the payment in order to process the order, in order to update the inventory. He's got to have everything depends on everything, and everything depends, and everything is part of the same synchronous activity. Then you have these points of failure. So imagine I got some items in my cart. I decided to make an order. I processed the payment, and then for some reason my inventory system is down, right? I already checked the inventory before I put it in the shopping cart, but now I wanted to update my inventory to say that the person has purchased it. But when I go to do that, that system is down for some reason. Maybe it's just, rebooting. They're pushing out an update. Who knows what's going on, right? But it's down. Now, all of a sudden, the whole thing falls apart, right? Because it's all in this one synchronous operation. And what ends up happening is, okay, now we have to recover all of this mess, right? Where it's failed, but the payment's already been processed, so we've already taken money out of the person's account, but we're obviously not going to ship it because we never got to make that call. So we've dealt with this problem in computing for a while. We have various models for it, such as transactions. In the world of database, where we can roll back the whole transaction, but that doesn't really solve this problem, because the payment, what we really need to do is refund the payment, because we've already taken the money out. So you can't just roll back the transaction and have it as though you never took the money out, right? So that doesn't work. But what we've figured out over time is that if you don't make these things synchronous, if you make them asynchronous, if you build in at each of these points what we call queues, so queues of messages, and on each of these, right, then the system can be what we call reactive. So what is reactive? And this isn't coming necessarily from me. This is actually from the Reactive Manifesto, which you can look up online. But a reactive system is first and foremost responsive. What does that mean? Well, that means that it gives you a consistent experience. That consistency could be that it always responds with the same sort of performance. It could be that it always gives you a not necessarily a positive outcome, in that maybe your order doesn't always complete, but it always fulfills the desire to either have the order complete or not have the money come out of my account. It gives you that consistent experience that you expect. In order to do that, it needs to be elastic. So it needs to be elastic, which means that it needs to scale with load. It needs to automatically understand that it's now under some sort of pressure and adjust to that pressure. And it needs to be resilient. So what does resilient mean? Resilient means that it needs to be self-healing, and that's because we always assume failure. It needs to assume that various components of the system are going to fail, and it needs to automatically recover from that. It needs to not have the whole thing collapse, like we talked about with that order system, but instead continue to be responsive despite those failures, right? In order to achieve that, it's all got to be built on messaging. Some people call it eventing, but I'm going to call it messaging. Doesn't really matter. The point is that these are queues of messages between systems, and this is what enables that, which is what enables that, and these two assist each other, because the ways that we are elastic are help us to be resilient, because we can automatically create new copies of the system to be resilient, and vice versa, right? So we need to build these what we call reactive systems. So that, as I said, when the inventory system is temporarily down, that message sits there until the inventory system comes back. The order then gets processed because to the payment system, because a message comes back from the inventory system which says, yes, everything's good. Now, the inventory system could come back with the message, no, while I was down, somebody else picked that item and it's gone now. And then the system needs to react to that by issuing the refund, right? So the system has to be able to understand all those various points of failure and react to them appropriately, right? This is where things get interesting, and where I think agentic opens up a whole new possibility, because I want to add another term to this picture. I want to talk about these systems being, and I'm going to put this at the core, adaptive. Right? So what do I mean by that? What do I mean by by them wanting these systems to be adaptive? So that a large part of the problem, which we kind of touched on in the last discussion, was that we have all these deterministic workflows that we've worked out, but we can't possibly work out all of the possible workflows that might happen. We can't possibly think about all of those possibilities. And that's where we run into this problem. The advantage of a agentic system is that the LLM is non-deterministic, which means that when it gets unexpected responses, unexpected inputs, it's still going to give a response. It's still going to be resilient. It's going to do something. It may or may not be exactly what we wanted it to do, but it's going to do something, right? So now, when we start to talk about those systems, right, we're talking about, okay, if I have an agent here talking to an agent here, and let's say we have another set of agents over here, right? So agent, we'll call this A, and we'll call this B, right? So agent A calls agent B, right? If it just sits around and waits for agent B to give it an answer, which is that synchronous model, right? We have a problem because if B, based on the input, says, no, I shouldn't respond to A because this is an unforeseen possibility, really what I should do is go and talk to C, right? And do something slightly different. If A is just sitting around waiting for that response, there's a problem, right? That system can't actually be adaptive. It can't actually change the workflow on the fly. However, if this is all based on a reactive or a messaging system, right? All that happened here was that A put a message on a queue, right? B can decide to respond to that on another queue, right? Or it can decide to go over here and message this guy on this queue, right? So he might decide not to do that. He might decide to message this guy over here, C, right? And then C might decide, oh, okay, I have enough information to reply to A, right? Or he might not. C might say, no, I'll reply to B, and B might go back to A, or B might go on to D, right? That's how the system needs to be able to operate in order for agentic systems to be adaptive and actually do what we hope they will be able to do. So we have to build our agentic networks on top of a system that is asynchronous in nature. So it needs to be, so we need to build it on a reactive system. That means it needs to be async in nature. Which means it needs to be message based or event based, if we want to use the word event, which means it needs to be based on queues. But it's got to be completely reliable. It's got to be built so that we know that when a message goes on a queue, it is eventually going to get delivered to the right agent. And what happens next may be non-deterministic, but we know that when that next agent puts a message on a queue, it's going to get where it expects it to get. And that all the pieces underneath, all that underlying technology is going to work. So it's super important that we build our agentics networks on this kind of reactive platform. And this is why I've joined the company Vantic, because Vantic is really the first commercially supported platform that I've seen that's truly built from the ground up to be this kind of reactive solution in the back end, to really have a truly reliable message-based or event-based architecture that allow these agents to talk to each other, but also to adjust the workflow as they need to adjust the workflow, and also comes with all the pieces that you need in terms of data storage, both temporary and long-term, but also the deployment aspects of it, the monitoring aspects of it, and the ability to do all of this with confidence and reliably deploy those solutions. So thank you. I hope that kind of clears up why I think we need to build our agentic systems. You know, agentic must be on reactive. So it must be built on reactive. And that there are solutions out there, such as Vantic, that allow us to do that. Thank you for hopefully coming up soon. I'm going to be talking about why I think agentic in healthcare is the right way to go. And also I want to talk about why I think the future of development is going to be uh, more like teaching than writing code. So look forward to those 2 episodes. If you've made it this far, appreciate a like and subscribe, and all those good buttons. And also love to continue the conversation. Comments are very much welcome. And you can reach out to me also on LinkedIn. And hope you have a good rest of your day.